I'm starting recording of the session. First of all, thank you all for joining the second part of the workshop. I've just a heads up. All the materials required for today's exercise are here on Power BI Workshop channel, on General, and on the files on day 2. You may download them now, so we can use them in our exercises later on. They are just one Excel file, one CSV file, and one Notepad document, which will help us with a couple of custom imports that we are going to do through the rest of the session. As you agreed, today we are mostly focusing on custom importing of the data, on transforming the data, and on data models that are required for Power BI. So in order for us not to waste any more time, let's get started. Last time we imported from Azure SQL database, and since database is probably the main source in the future for all of you, we will start with some custom import from Azure SQL database. You know the drill. We are choosing get data field. We are choosing more. And we choose Azure SQL database. We try connect. Now we in helper file there is on repository you may find access credentials, address of database, and so on. So we'll just paste the server here. We'll just get the database here. It's Adventure Works LT, and we won't do any of those data connectivity mode. We'll just go over to advanced options, and we'll paste some statement inside. So we are not limited to only importing entire tables, sheets, or something like that. We can choose only specific fields that are required for our analysis in Power BI. So I prepared also one simple statement. Here it is. You may find it here. I'll copy it. I'll do just paste. That is a SQL statement, which is choosing a couple of columns from entire database. It is calculating sum of profit by product, and this query is really simple. We can add more to it. We can add some discounts we are having. We can add freight costs from dataset, but just for this exercise, we chose the most simple query that we can apply here. So just we can click OK. And we click load data. And we will name this query as a custom. Okay. What will happen if we try to get entire database like we did in previous lecture? When we try that as well, we repeat the exercise, get data, we choose more, we choose Azure SQL database, we click connect, we paste credentials that are required for us to connect to there, and we choose import. Okay. And we choose a couple of tables for importing. I'll choose sales order detail and sales order header. I'll select related tables as well. And I click load. It is loading, it's populating our Power BI model. And as we can see, although we did one custom query on the same database, and we chose specific tables for the database as well, this tool is giving us flexibility to import numerous views. Actually, numerous are perceptions of data, not only tables, but we can in the same time import some custom things. We can write a query. We can do everything that we require. But here's the thing. As you can see, we have a lot of data now in our model. We imported a couple of tables and everything. If we want to refresh the data,
Sorry,
yeah.
Moaz, to interrupt you. Just a small remark. There's some noise coming from the background. It's like constant tapping. I'm not sure from where, but
constant.
Like it's like constant, like constant tapping on the microphone or something similar to that. I'm not sure from where exactly, but I don't know, guys, if you hear it.
Those are probably, I had really some issues with the mic from this morning, so I'm trying to hold this headset mic as close to my ears, to my mouth as possible.
Okay, sorry to interrupt.
That may be an issue. I'll try to minimize that in the future.
Thanks.
Thank you. Anytime. Okay. We are having a couple of tables imported. Those are sales address table, that is custom query we created and everything. And if you want to refresh the data, only what we need to do is just click on the refresh button here. Click refresh, and it will fully refresh data that is coming from our data source, in this case, table. Okay, so I want to go next to transform some of that data. As you can see, while we were getting the data from data source, we had two options. We had an option to load the data, and we had a option to transform the data. In example, I'll choose just one simple Excel document. I'll click open. And here we can see two buttons: load and transform data. I won't import this Excel now. I'll do it later. But just so you can see that we have on this step we have two options. We can load the data as is. We can transform it, and we can transform the data from this button here as well, where we can go, okay, let's click, let's transform the data and see what we can utilize from this. So we click to transform data. It will open us another window, and here we can transform every table that's imported, and this is really important to remember. Power BI represents everything as a table inside its model. What does that mean? That means if we import an Excel file with multiple sheets, each sheet will be represented as a table. If we import couple of tables from database, each table will be represented as a table. Actually, that makes sense. If you create a custom query or something like that, it will be looked upon as a table. So That also means if we import something from web, like currency exchange, we will see it here below, and as a table, of course. But here on the left-hand side, where I'm pointing my mouse, you can see that those being called queries. Okay, what is query? Query is a set of instructions. I won't go much into deeper details about queries. A set of instructions that is fetching our data from below, from somewhere. And like I said, each and every Power BI represents everything as a table. So we can say that this table is a query. Why is that important? Because of the following behavior of Power BI. When we are importing, let's take this table for an example. When we are importing this table, it's not a process that's been done only one time. Power BI remembers following information. Remembers the column names from that table. Power BI remembers connection to the data source from which we imported that table. If we are importing from database, connection will be okay to the database. If we imported from some Excel file, connection will be represented as a file location and type of file. So that way, data that is currently located within Power BI, this data is not important. What is important is that query, that metadata about table itself. Where is it and what columns it has? Why is this important? That means when we refresh the data within the Power BI, it only replaces the data or append additional rows to the table itself. So Power BI remembers in the first place, it remembers that metadata and that query. Let's go on the right-hand side. Each query within Power BI have something that's called applied steps. What does those applied steps means? Let's take for an example. If we want to delete this particular column from Power BI itself, we just click OK, right-click, remove. And on the applied steps, you can see that another step was added. So based on this, what will happen when next time when data is refreshed? It will happen that, like I said, Power BI remembers query, remembers metadata. It will say, okay, this is my source, this is my navigation, and I have removed column. So so Power BI remembers not only metadata, but steps that we undertook to transform our data. Did anybody heard about script about M language from you guys? Nobody? Okay. I'm going. I'll go now more about some IT details here. How does Power BI remembers all those steps? We can see those visually displayed. We have a removed column here. We have another step, removed column here as well. And Power BI remembers it using one language that's called M. We can go to Advanced Editor button that's located here. And this is how 1M script looks like. You don't have to worry. Usually you won't use M language. It's simple. It's simple, but I don't know. I just want to show you what's in the background. and how Power BI is evaluating or looking at the data sources that we are transforming. So something M is behind. You can see it has some source, it has some databases, and so on. I'm not going into details on this. What's important to remember is that it's not the data that matters. What matters is that connection to data source and this query or table that can be constantly refreshed as our needs are requiring for this. Let's about transforming options. Like I say, some sources from entire this logic of this tool are coming from Excel. So everything that you have used in Excel, you may use here as well, and much more. To be honest, you can.
Moaz, can I ask something?
Okay, go ahead.
Regarding this fetching data from source, you use two types of fetching data. You use custom scripts to select data and fetch, and another is just to select table and fetch all. And after you fetch all, you remove columns that you don't need. What is the best approach? What is the faster solution?
Well, it depends. I just wanted to show you that this purpose of queries and tables and how Power BI represent. And regarding best approach, it depends of couple of scenarios. For example, if you are familiar with the database itself, if we know where data is located and everything, and we want to limit some data that we will import into Power BI model, the way to go is some custom query. But if we want to do some data exploration or from database or everything, I suggest that we I don't know, go with the old tables. Usually there's how can I say, one of the approaches, let's take this data portal for an example. Approach there is to create some views under a database that will serve as a custom queries, and we are importing those views. So we limit the data, limit the columns we need, and so on. So basically, the answer is it depends on the scenario that we are trying to achieve.
Okay, thank you.
Anytime, but the best would be to limit to somehow to limit and actually not to import data that we don't need for our analysis. I mean. This isn't this isn't an issue when we are dealing with small set of data, but when we are dealing with huge amounts of data, we definitely should go in the direction of removing all unnecessary data from our model. Okay, here is how it looks like. I want you to remember this is the queries. Power BI remembers steps we undertook, and Power BI represent everything as a table, and that's really important, because thanks to that constant refresh is enabled, because with every refresh Power BI goes through all those applied steps we undertook. About transformation, I want there are a lot of options here. You can have some options on this here tab. We can remove columns. We can remove columns we need using this button, or clicking right click to the column and saying, okay, remove it. We can remove rows. We can remove top rows, bottom rows, alternate rows. We can Power BI itself can remove duplicates. We can remove blank rows and so on. We can do some operations with splitting the column. I mean, if we have a, for example, if we have full name, we can go and say, okay, let's split that column into first name and last name. Glue by. Important thing here as well. We can change column type. Okay, let's. I'll change the standard cost from fixed decimal number to whole number, an example. And as you can see, that transformation reflected in the steps on the right-hand side. Okay, I figure out that's not something I want to do. To undo the change, I'll just click on the X located to the left from the step we applied. Okay, on here. On its transform tab in Power BI interface, we can do transpose rows, we can do reverse, we can do count, we can detect data type, rename, and much more feature. I mean, it's everybody who kind of worked with Excel can utilize those features as well. Also, that's it for now. I'll do close and apply. Yeah, after we finished all of our transformation that are required, next step we should go is just click here. We can say, okay, only apply, close and apply, which means, okay, apply changes and close this edit query window. And we can only close without making those changes. One more thing, I forgot that to mention within transformation. Let me see if we have some date here. Okay, date. Power BI usually detects all types. Usually, when I say usually, I say it's the best for us to go and check was it really correct. Typical error that we will have when importing some data values is that sometimes they won't be recognized. And why is that? In majority of cases are regional settings. An example from our regional settings on our laptop are differently interpreted. An example, date format in our way looks actually date, then month, then year. And if you are taking US setting, for example, it goes month, then date, then year. So that's one thing just to keep an eye on, those regional settings. Okay, we are satisfied with the changes. We will go now to close and apply this. And Power BI will apply those changes and get us back to our reporting window. We can go anywhere back to transforming data. Just click the transform data button, and we can do in any step whenever we want. We can just transform data there. Okay. Are there any questions before continue with the modeling part? Guess no. Okay, that's awesome. Are there any of you guys who didn't use any or SQL joins or VLOOKUP if we are looking at Excel? I mean, is there anyone among you who does not know how to one or joins or SQL join or lookups? Guess not, but never mind. I'll please forgive me. I'll go really basic on this. So okay, in the files I prepared for you, you may see two documents. We can see sales, and we can see salesperson. And okay, let's open that document. Here, I'll open sales first. Open sales first, and I'll see some sales. Nothing special, just one table, one sheet that's filled with sales. We have a salesperson, we have country, we have territory, blah blah blah. We have some date and it's ordered. We have some unit price. We have a couple of columns. Let's go to the salesperson. This is a CSV file. I'll open it now. We have all in this table. We have some data about the person who is making those sales. We have the region, we have the city, we have their first name and last name, and so on. Let's look at this situation. What if we want to create report from different set from multiple tables? I mean, there's a common scenario here. Data is always not located in tables. We want the same table. So if we want to look into multiple tables as well, we need somehow a way to connect that data. And how do we connecting it? By common columns between those entities. Let's take one quick example in Excel here. If we are having, I don't know, some table that's called I don't know, some table that has columns called the table exams that have exam ID, exam name, and it's 1, 2, 3, or 4. And name is like I say, it's math. It's history. It's science, biology. And if we have a different table called grades, where we have a grade ID, ID, and grade value, and let's say it's 1, 2, let's say 7 rows. We have an exam ID 1, 1, 2, 2, 3, 2, 4, 2, and 1. And grade value are 60, 50, if we want to calculate an average by exam, we need to fetch data from two tables. So somehow we need to join two tables. And how are we joining it? We are joining it by the similar columns from two tables. So basically, just majority of you already knows this really good, but if we want, this is a basically, I won't go much into details on that one. If you are stuck on this part, just give me a call or ping me or something like that. But the point is that we can join two tables to extract and visualize common data in here. And the question is, how is Power BI doing that? Power BI is doing that like this. Remember those tables we imported: customer, sales address, customer product, sales orders details, and sales order header. Let's go on the left-hand side. Let's go to the model. Okay, let's do this. With each and every table that we imported here, we are building our Power BI data model in the background. What does that mean? Power BI is naturally trying to find all connections between different tables and try to utilize them as much as possible. For example, how does do it? He does that automatically. He's reading, Power BI is reading names of tables and connecting all those tables between itself. Why is this important? It is important because of this. If we want to get profit or total sales by a customer, we need to go into two tables. We need to go we need to go to let's say by customer first name. Actually, by I actually will go with company name. If we want to get all sales by this, we need to go. We are looking first in table that's called customer. No, I believe actually that product is a better for this. If we want to get all sales by product, we first take here name of the product from this table here, and from sales order let's say header. We are collecting a different amount for that. So here's I know there are similar numbers. Somebody noticed, but I'll get to that as well. That's the purpose. We need to go into two types. We need to go sales order two tables to sales order header to get all the cost, all the profit we're making, and we need to go to table product for that. For Power BI to being able to do that, model needs to be created. Model needs to be created, and those lines here, those connections, is something that's giving us this ability to navigate and to go with the data. Model is probably the most important thing here. With good model, we can do everything. Our reporting can be okay. Just drag me some columns from here, and drop me here, and get everything. But if we don't have a model that's properly set up here, that means that we cannot utilize reporting as much as we need right now. Here, when you see same numbers here for each and every product, that means that can only mean one thing: that our model is wrong. We did something that's not okay there. So we need to go and to revisit how we are building a relationship with the model. We'll remove this visualization for now. We'll go to the model, and we'll do following. If we want to add a relationship here, I'll just go and remove, I don't know, I'll remove this relation here, just mark it, go delete, remove it. We have two options. First options would be to go right click and to go manage relationship. And we say two things. We can say auto detect. Okay, Power BI, please go detect all the relationships between the tables. Or we can do it ourselves to say, okay, let's click new. Let's pick table and columns that are related. In example, product and sales order header. And we can see that we don't have relationship between those tables. But what do we have? We have a relationship between those two tables. And relationship is, as you can see here, is by product ID and with product ID. And on that particular method, we connected two tables. There are a couple of more options here. There is something that's called cardinality, which needs to be one-to-many or one-to-one. We have a cross-filtered direction. When we get to the filter context, this will make more sense. Currently, I'll leave it to both for now. And click OK. Let's say close. Second way of us creating a relationship between table. I'll delete this one again. Go delete. Yes. I will just drag product ID to product ID here, and it will get me relationship between those two tables. This is highly important. Every time when we need to do some modeling, Power BI will automatically apply, but we can trust the Power BI. We need to look into our relationship ourselves. For those of you guys who will be using a data portal, I'll take my Mistral for example. This model will be already defined, so there won't be a need to go much in depth about data modeling and so on. But just so you know, the most important, actually one of the two most important things is that we have a proper model that is set and integrated here as well. Okay. Okay. So before me trying one more exercise, I'll import the additional two files we prepared for this. So we need to go to get data. You may find those at files I've uploaded. Go to get data, choose more. We'll take Excel, for example. I'll say connect. And I'll choose sales. I'll click open. I'll choose sales. And I'll just say load data. Next thing I'll do, I'm going to get the data. I'm using CSV. And I'll enter salesperson. I'll click open. And here I will go on following. I won't go load. I will go to transform the data. I'll click transform data. And I will add a custom column located here. We will choose. We can see that we have first name and last name separated here. Okay, we want another column that's called full name. So in order for us to do that, we can go to add column. We can go to add column tab above. We can go to custom column. We'll call it full name, and we'll do following. We'll just double click first name. We will add concatenation operator, and we will double click on the last name. This is how formula for some looks like when we are using Power BI to add custom columns. We click OK, and we have full name. We will now close and apply. Go to home, go to close and apply. And we have loaded both of those our Excel with the sales here, and the CSV with salesperson here. I'll just rename it so we have an easier manipulation of that. Instead of sales, I'll just say e-sales, and instead of salesperson, I'll rename it to e-salesperson. What I want to demonstrate here, if we go to the left-hand side and click data and click e-sales, we can see the salesperson here is a full name. And if we go to e-salesperson, we can see that first name and last name are separated. Reason why I added the full name column here is so we can connect these two tables. And how will we connect those two tables? We go to model, we find our new tables, e-sales and e-salesperson, and we connect them using just give me a second, using full name and salesperson. What does that mean? Power BI will not auto-detect this type of relationship. Why? Because they are having different names and so on. But just want to keep you in mind that you can connect and relate tables through text fields as well, as long as one table has a unique values of that. In example, our salesperson have a unique values of salesperson. On that, we created our different, we enhanced our different model here. So if we are going to do simple reporting here, let's say for example, we want to summarize sales by state province name, which is located in two tables. We just click state province name here. Okay, click. I won't go now into visualization. I'll choose table visualization, and we go to e-sales and say, okay, I'll say, I never mind. This won't be true as well. I'll take unit price. Actually, if we want, actually, I'm changing what I said. I want to calculate average unit price by state province names. I'll just click here. What's the best here about Power BI? He is doing aggregation averages by its own. So he is taking all orders that are made on Alberta, for example, and in this case, it sums them up. In case that we want some different calculation to do that, we can choose average. And we got basic table that has already pre-calculated averages of unit price for every state that is in our data set. And this is really an awesome feature. It does all those aggregation, averages, and everything by itself. So I have one more thing prepared for today, and that's we learned how to add a custom column, and now I want to add something that's called measure here. How are we adding measures? Measures are like let's say for example we have our yearly sales here located, and we want to calculate something that's called month-to-date sales. So in example, how much we sold comparing to previous month or so on. Those type of columns are called measures. And Power BI has two ways of adding those measures. We can go to the on the right hand side. We'll choose this custom table as our basis. We go to more options. We create. We can choose new measure or new quick measure. I'll choose new measure, and let's assume I want to calculate total month to date for each and every of the for each and every let's say unit. Sorry, I've lost it. Go again. New measure. If I want to calculate my total month to date, entering this formula. Actually, paste is not working at this point of time, so I'll just find it. Profit MPD equals to total month to date sum profit sorry, name this column to be profit. Sorry if I'm going too fast. I'll say I'll sum for profit. And I'll add sum it up by and we created one I measure. What's behind? It's language called DAX. I won't go into DAX on this basic workshop. Just so you can know that you can use DAX to calculate a different type of measures or any other calculation you require. Let's say, for example, you want to add a measure that is I don't know, calculating something called running total or some different metric. Let's take Mistral, for example. If Mistral wants to calculate their running total of the employees, they need to add a measure that will reflect that state. Different way to adding those measures is clicking on all those three dots and go new quick measure. Since DAX is I don't know, complicated for everybody who is first time facing with DAX, Power BI has something called quick measures that already has a predefined, pre-calculated measures that can be used. We have it running totals. We have a quarter year-to-date totals, and everything. Those of you who were in financials can mostly relate about that. And let's say I want to calculate average per category. I just choose which measure I will be calculating. I will choose some of my base value. Let's say base name and cat actually it's profit and category is name and click OK. And it will make DAX in the background. And as we can see here, if we choose another visualization, we can go with the name and we can utilize this newly created measure to give us what we want. This is I don't know. There is no much details right here. This is just to show that you can add custom calls, you can add quick measure, and to rehearse. I want to keep in mind that one of the two most important things here at Power BI is how do you set up a model and how do you utilize it. I would wrap up this session. I mean, from my point of view, this is the most boring lecture. And the next week, we are going to the fun ones, and that will be reporting, filters, and visualizations. And glad we got over this already. If you have any questions, just ask. That's it from me.
I have one question. Do you find it easier to do this modeling and measures in different kind of language like Python, R, and similar, and then to visualize it to in Power BI, or because I see a lot of learning curve in this kind of transformations now, from my point of view.
Okay. Okay, I won't go with the typical answer. Depends. For some type of measures, I mean, for example, running totals, month to days, and so on. DEX is quite natural. You can go. I mean, if you are comparing SQL and DEX, it's light years ahead of simplicity when we do some things in DEX or other than SQL. But like you said, for Power BI, it's not big learning curve. It's, I don't know, will get done for classes, but for DAX and modeling, it is. So my suggestion, my point of view on that is something that I did for many cases, to do majority of modeling before going to Power BI, to model a database, to do everything, and just utilize Power BI for already predefined, pre-modeled measures or anything I've used. So if you know DAX is in majority of cases way to go. If you don't know DAX, you won't lose anything if you model it on some other part of the system.
Thank you.
Anytime. Well, if we don't have any other questions now, for those of you who know who already worked with joins, it's easy. Who doesn't, it will sink in. I would conclude this lecture and see you on Tuesday next week when we'll finally do some cool things with visualizations, filters, and so on, and which is, I don't know, it will be more fun than this one. Trust me, I know. Thank you all for attending. Thanks for attending.
Thank you, Moaz.
Thank you. Bye-bye.
Bye.